Okay, can I start?
Yes.
Okay, so hi guys, this is Sadiq and I'm going to talk about the Wireshark and ethical hacking. So the presentation includes three outlines: introduction, the about the Wireshark and how the Wireshark actually performs the capture, and the second is the how to capture frames packets using Wireshark and different layers in Wireshark when the Wireshark captures the traffic data. So first of all, introduction, by using Wireshark, which we can capture voice packets that are voice calls, VoIP calls, and replay them the entire conversation that took place. And we can also use Wireshark to see the routing updates. Routing updates meaning the what is actually happening in the network at the time or at the communication, and see what's going on inside the network. What kind of protocols are taking place between the two devices. If there are two PCs or the switch or the relay or the server, we can see everything. So in general, for the virtual infrastructure, as you can see from the figure, there are two PCs and there's a one relay and there are two switches. So we're using GNS3 software to run a virtual infrastructure, and for for a point to be noted here, Wireshark is very compatible and is already integrated into the GNS3. So we have two PCs. This is the PC1 and this is the PC2. We can see these are the VoIP telephones, virtual telephones, and with the address 1001 and 1000, and both running IP phones. These two pieces, and using Wireshark, we can capture the traffic. We can see a lot of protocols such as STP and CDP and EIGRP and MDNS TCP. These are all the protocols, but we are only concerned with the VoIP calls. So for that, we are going to see the skinny client control protocol, which is used between phones to the router. And this is the PCAP file that is generated by using Wireshark when the capturing is done. And this is, we can see the entire conversation that took place and what the Wireshark actually captured in real time. This is the time is shown on the left side, and the source address meaning the for example the telephone one, the send the data to telephone two. This is the destination, and uh, and the destination is now a source, and then the it sent back what it as a reply to the 10.1.2.1. And all of this conversation took place by using the skinny protocol. But in order to see the VIP calls, we must use UDP traffic, and here we want to see the VIP call setup. So UDP traffic is uh, basic, and it's only concerned with the VoIP calls. And Wireshark capture details to of call being set up even when the calls end. You can see from this part of the picture, the start time and the stop time, and the initial speaker was this, and from 1000 to 101, the protocol used the skinny, and the duration took only 21 seconds. But we can see that the even after the call was ended, the status is also captured by the Wireshark. So this is the source, and this is the protocol used, MDNS. All the but this is not the actual detail. The actual details are in here: the frame, Ethernet, Internet protocol, and user datagram protocols. So first of all, now we're going to see first scenario was the voice call, and now we're going to capture the browsing. One PC browses a website and to a server. So we have a virtual browser, and in order to capture the traffic, but first we must build the structure which has a PC router and a server. So here we have a PC. We have actually two PCs, but we are only considering PC1, and there's a server and a router. So when we are browsing this address 10.1.1.100, and this is in the virtual network that the browsing is taking place. And this is the natural, you can see the Windows 10 VMware. This is the virtual Windows and the virtual browser. And this is the IP address to that browser. And now for the server, when the PC asks the server to send the web page, the server serves the user by the HTTP protocol. So in order to use the HTTP protocol, uh, we from the figure we can see that we are filter out the HTTP and the entire conversation, the entire communication that took place between the PC and the server is right here. This is the source IP address of the source, that is the PC, and this is the server. And the protocol used is the hypertext transfer protocol. We can also see what the PC is trying to get from the server. This is the get, and this is the protocol used, and the PC is trying to get the text, the HTML, the website, which is a basic one. This is the a basic website with a picture and the title and some information. But point to be noted here that this is a clear text, and which is a very bad idea to be used in nowadays. It's also a very bad practice because Wireshark and this clear text can be easily captured without any extra computational required. We can also download this logo as well, this picture, because Wireshark also can capture this data because the server is sending the entire web page to the PC. So if the Wireshark is capturing all the data, so the picture can also be downloaded as well. And you have to change the PNG format to a PNG. Okay, so talking about different layers. In HTTP, there are different layers, as you can see from the OSI layers from 1 to 7. But when we in networking as a whole, frame is known as a layer 2 of the OSI model, which is related to data link. And so information captured here is known as frames, and it is also known as Ethernet 2, which is the most commonly used word. So Ethernet 2, this is the one. This is the second layer and is known as frame. But so if we look at this picture, what the Ethernet if we capture the details here, the traffic here, what we can get is that we can know the MAC addresses of the source and the destination, and we can also get the information about what type of protocol, IP, internet protocol is used, which is the version 4. So in the third layer, the other layers, third layers, we have the packet. This is the packet which is related to network. And here IP version 4 is captured, and so the protocol is also IP Internet Protocol version 4, which is related to latency and throughput. And in layer 4, we have a segments which is related to transport. So if you understand what the OSI layers are, the data link, the network, and the transport, all these four layers use different protocols in order to offer to done specific tasks. So in layer 4, transmission control protocol is used, and here the client uses random ports, but the server is has the port which is the well known. In layer 4, in layer 3, IPv4 offers a lot of information. So let's see. First of all, differentiated services code points is used. It is related to quality of service. We can filter out the what kind of service we want as a priority, and the others are left are not that important. So we can also see a lot of information which the Wireshark captured: the time to live, then the fragment, the identification, the total length, and this is the DSCP protocol which is the used, and the source address and the destination address. In layer 4, TCP, which the client uses as a random port number to a well-known port number. Here we can also see a lot of information. Source port is 4961676. This is a random port number, but destination port number is 80, and this is the well-known port number. And it actually makes sense, because if the destination port number is not known, is random, so how can a source actually send and request the server to any kind of information to acquire? So this is the port destination port number has to be well known. And We also have the visual details about the sequence numbers and the acknowledgement and what the information was what the communication, how the communication took place between the 2 points, and what the TCP payload was. So okay, so in layer 5, which is the hypertext transfer protocol, and this includes the application layers and all the other layers, the presentation and the session layer. In TCP, in hypertext transfer protocol, we can see this information which is related to what the server served to the user, the PC. First of all, the get HTTP, this is the one which the PC asks the server to request the server to send. And after that, the server accepted, and we can see the address, the text, the upgrade, the user agent. We can also, by capturing this data from with Wireshark, we can see the information, the what kind of browser the agent, the user, the PC is using, and what Windows version is installed into the PC. And this is the host address and the connection, and the many other types of information are available. So these are the two scenarios which we looked in the presentation. First was related to voice call, and that took place between two virtual IP phones, and another one is the website, the one PC, a virtual PC requested a website from a virtual server, and how the server served that website to the PC. So thank you. If you have any questions, you can ask.
Okay, thank you, Sadiq. One question, did you analyze the case when you have HTTPS?
Hypertext transfer protocol?
Yeah, secure hypertext transfer protocol.
No, Professor, I do not.
I mean, can you try it? Can you now, if you are on the laptop, you can quickly maybe access HTTPS and see the difference. Let the students see the difference.
Professor, I have not built the infrastructure, virtual infrastructure.
Okay,
Right.
you can
Yes.
try it. You can try it to see the difference between, to
Yes.
see the importance of the letter S, secure hypertext transfer protocol.
Sure.
In secure hypertext transfer protocol, you will not be able to see all these details.
Yes.
That's why I want you to see the difference, because nowadays all the web, everything on the internet is being secured using HTTPS, not HTTP. So that's very critical point. Any questions to Sadiq? By the way, thank you for the presentation. You presented some new information. There are some similar things to the previous presentation that Yazid delivered, but you have also mentioned some new things. So, so what about the others? The others are preparing the same thing here. So I think guys, you need to explore new use cases for the software. Now your friend present, yes, we have two students presented so far. Don't present the same material. We already know this. The purpose of your presentation is to teach us something new. Now those two presentations are basic fundamentals. We want you to search for something new, exciting about this software, new use case, new scenario, new application, new thing you can do with this software, and present it to us. And I want you to get to have hand-on experience with this software. Get your hands dirty with it, play with it, do some stuff with it, break things, simulate things. I don't want to just repeat the same presentation over and over again. We need to hear something new, learn something new, and your friends will get bored of it, yes, if we keep presenting the same thing for them. We need to give them something new. Everybody benefits. Yes, the same way Yazid benefited you, you need to benefit Yazid. Yazid brought something for you, bring Yazid something, present something for him, and the others, and me as well. So this is the point. Now it was easy for Yazid, and this is the thing. The people who take action quickly, they can find easy stuff and present it. I mean, you don't need to invent any new things. But the more you delay the submission of your presentation, the harder it will get. Why? Because all the basic stuff, all the basic things, the easy things are being presented now, are over. You are not allowed to present them. Now, you are not allowed, the people who will present after Sadiq and Yazid are not allowed to present any material related to what Yazid and Sadiq presented. We already know this stuff. Now I want you to bring us something more, something we don't know, something different, something more exciting. So this is a trade-off. If you present early, your presentation will be easier. If you delay your presentation, you will work harder on preparing some stuff that was not presented before.